Alright, so now we're going to talk about changing quadratic relations from vertex form. Remember, your vertex form looks something like this, right? And in this section, you're going to change it into something that looks like the stuff that I'm going to highlight in yellow, right? So it involves taking this information and knowing what its vertex is. We can use that to figure out what its vertex is, but we can't necessarily find out what its Y-intercept is right away. Okay, like this one is awesome because it automatically tells us what our vertex is, and then gives us an idea of what our steps are for graphing our parabola is, right? But it doesn't really lend itself to giving us our final equation, which will give us this final equation called the standard form, which will give us something interesting. Okay, now this question here asks us to show algebraically that y is equal to ax squared plus k is the same as some equation that's in yellow, right? So when we're doing this, to change it into this, it means we're going to talk about expansion, okay? So we're literally going to change these equations into those standard equations. So we're going to expand it. So for this problem, we need to expand. So we take the x plus 2 and change it into a vertex because we know how to calculate that. So now, once we've done that, we're going to take x plus 2 squared and we're going to start expanding it to see if we can get it to look like this. Alright, so now let's go. Alright, so we just started expanding and we end up with something like this. We've studied this before. Okay, you'll notice that for these brackets here, right? These brackets represent the calculations that I'm doing for this expansion, right? You want to make sure that you keep your brackets until you have simplified everything in this expansion. Okay, so the only thing that's left to do is to bring those two together. Okay, so let's do that. Now, when you do that, you've got this. Notice I still have my stuff in a bracket, right? It's because I just finished it. Now that I've just finished it, I can get rid of the bracket. Now notice there is nothing in front of the bracket, so we can just drop the bracket, okay? And when we drop the bracket, we just have to add up or collect the like terms for the last two numbers, 4 and 1. So you end up with y is equal to x squared plus 4x plus 5, which is exactly what we expected. Now, you'll notice we're going to go and check something on the graph. Okay, so let's go straight to the graph and make sure we understand what we have here. So here's our original equation. Y is equal to x plus 2 squared plus 1. And you'll notice if I zoom in on there, that point is actually 0, 5, which is what we expect for the y-intercept, right? It's awesome. It worked perfectly, right? So the key here is, if I know, and if I expanded, we knew that when we expanded our equation and we got to the end, we ended up with this, right? Then when we let x equal 0, if we don't have a graph, we let x equal 0 and we can solve. Or, here's the best part, if you have something in standard form, the y-intercept is literally the last number in our equation. So remember, with a parabola that's in this form has a form in this. To get from here to here, you must expand, and when you get to this form, the information that's held in this problem here, right now you know that the whole number or the constant at the end of our equation is the y-intercept. Okay, so let's go on and let's consider the next problem that we have here. Okay, So for this problem, we can easily see that the vertex is opposite world 1, comma, -5. All right? And the next thing we have to do is we just have to expand it. So this part here, the x minus 1 squared, is just repeated. And all we're going to do is we're going to focus on this part, and we're going to keep our brackets right up until the end. So let's do that. So we've got y is equal to -2. Notice it's -2 bracket the expansion of this. So x times x is x squared, and x times -1 is minus x, and then -1 times x is -x, and then -1 times -1 is +1, right? And you'll notice that I have it in brackets just like I did before because I haven't finished the expansion of the brackets yet, right? So now if we continue, the next stage we end up with y is equal to -2 bracket x squared minus 2x plus 1. So what we have to do now is we have to imagine, this is very important. I cannot emphasize how important this is. We're going to take the 2 that's sitting in front of this, and we're going to multiply it by everything here, because Bedmas tells us that if we have a multiplication, we have to do it first before we do any more addition or subtraction. So there's a multiplication into everything in this bracket. So let's do that. So we do that, and we end up with -2 times x is -2x squared. Then -2 times -2x is +4x. And then -2 times +1 is -2. So then we have that, and then we still have to subtract 5, don't we? Okay? So now all we're going to do is collect our like terms, right? Our final answer for our graph, for our standard form of the equation, is y is equal to -2x squared plus 4x minus 7. Now from before, if x was 0 and we wanted to find the y-intercept, set it to be 0. That goes away, and you're left with -7, which means it's -7, right? Or we could have literally just read it off the information from our graph, from our equation here, our final perfected equation being -7. So we're going to write -7 here, and the a value is 2. -2. All right? So here's what you need to answer. We're going to write this out. So when we have an equation in standard form for a parabola, and you don't know the vertex, but you do know the a value, and you do know the y-intercept, right? For example, if I look at this equation here, 0.5x squared minus 4x plus 11, we know that it has been compressed by 0.5, right? Remember, a is less than 1, right? And it's still opening up, right? And the y-intercept is 11. We're done. That's it. And now, imagine I've asked you to write a relation, right? Where we've got this. A vertex of -4, 0, and a is 1. If I don't tell you what the y-intercept is, all you have to do is write your equation like this, right? Because you know you have positive for opposite world for x inside the bracket, but then you just copy down your 0 for your k, right? Because that's what your vertex is, right? Your vertex is the opposite of this, and then the exact number of this for your number. So now all we have to do is expand this problem. So let's continue. So now when we're expanding, this really means 1 times x minus 4 squared, because 0 is nothing, right? And then 1 times anything is just, whatever, nothing. So that's why we just have x plus 4 all squared. So now what we're going to do is we're going to double x plus 4, right? I'm going to also let you know that this is the simplified vertex form, okay? So now when you continue, right, we're going to expand this, right? So we're going to change it to standard form for our simplified version, right? And all it means is we take x plus 4 squared and we just expand it. Boom, 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 to there, and then boom, there is our y-intercept. And guess what? We're done. All right? So when I ask you to write something in vertex form, you could leave it like this, but then if you simplify it, this is our simplified vertex form. So that is what we normally see in the back of our textbooks. All right? Okay, so for this problem, right, we have y is equal to negative 3x squared plus bx plus c, right? And they tell you what the vertex is, right? Now, every equation has some form of information in there that we can use. Now, remember, the a value that is in the vertex form is the same a value that you would find in your standard form of the equation. So that means that the minus 3 on the x squared is the a in our vertex form. So we end up with this. Okay? So remember, if I have 2, it becomes minus 2 in our vertex. If I have 1, it goes here, right? So the y goes outside and it's exactly the same. And now, here's what we're going to do. Now, what we need to do is we need to calculate the vertex to the standard form. And to do so, you're literally going to start by doing this. Now, why is that? Why do I have minus 3 and then x minus 2 here? Well, the reason why that is because of this 2 that we have here. It's telling us that we have to double x minus 2 in order to expand it. So we're literally just going to expand it. So you'll notice I've got minus 3, and then I put a bracket for my expansion of x minus 2, x minus 2. So we end up with this. And then we add plus 1 on the outside. Now, once we've done that, we're not done. You can't just go and take this minus 3 and put it in here. We still haven't finished our work for our expansion. You'll notice I have minus 2 and minus 2 in here, minus 2x and minus 2x. So what we got to do is we have to simplify those by adding those together to get the following equation. You're going to get y is equal to minus 3 bracket x squared minus 4x plus 4 end bracket. Now, the reason why we have that end bracket and then we add the plus 1 is because now we have to take our minus 3 and we have to do something to it. Okay? We have to take that minus 3 that's in red and push it onto each one of the terms inside the bracket. So you get minus 3x squared minus 12x plus 4, and you'll notice it doesn't have any brackets anymore. And the reason why that is because we've expanded it. We've distributed the 3. So now, the standard equation for this problem is this. Y is equal to negative 3x squared plus 12x, and then, what do we get here? We have to add these two. So we got minus 12 plus 11. So this is called collecting like terms, so we get minus 11. So this tells us the y-intercept is negative 11. And we're done. Now, you could have also said B is 12 and C is negative 11. But we'll only just say that the y-intercept is something. So now, for this next problem, you've got this basic equation. Again, we've got our a value sitting in front, right? But now it's telling us that the minimum is 3 when x is 4. They're doing this to confuse you. That's the only thing. So here's the rule. When you've got a vertex, right, it's always the x first, right, and then the y value, okay? Okay? Now, if you think about it, x is here. X has been given to you already. X is equal to 4, right? But the minimum is 3. So this part is your y value. So your vertex ends up being 4 and 3. Okay? So 4 comma 3. Now, remember what I told you earlier. Our equation has an a value here, right? Now that a value is 0.5. So we can come up with the vertex form of this equation. And this is what we get. So remember, that 4 is opposite in our bracket here, right? And the 3 is the same outside of our bracket for our y value, our up, down. Okay, and then we use our a value for our equation. So now, let's go. So now, when we go and do our vertex to standard form, right, what you're going to do is you're just going to write out everything that needs to be done. So you got 0.5, x minus 4, x minus 4 plus 3. Now, why is that? The reason why that is because we have a squared on our x minus 4. So that means both of those have to be expanded, and then we have to do our distribution. Okay? So it's x times x minus 4, and then negative 4 times that. So now we end up with x squared in our second equation minus 4x, and then plus 16. But notice the 0.5 is still up front because we haven't really finished our calculations inside. So now we get 0.5 bracket x squared minus 8x plus 16, still in brackets, plus 3. So we've almost gotten to the final form. So now we got to take the 0.5 and multiply by everything on the inside. So now that we do that, you're going to get 0.5 x squared minus 4x, and then plus 8, and then plus 3. And we are almost at the final form for our equation. Okay? All right. So now, the final equation is this. And sorry, the standard equation is this. So we're just going to write y is equal to 0.5 x squared minus 4x. All right, and remember what I told you. We have to add the 8 plus 3 to get 11. So this tells us the intercept is 11. Right? So I could always ask you what the intercept is. Okay? So now, remember the 11, the number that's at the end of our expansion, our standard equation is always the y-intercept. And remember, we always have to add before we get to our final form. Okay? So now, let's go and work on this last question of the day. So it needs to tell us, it's asking us to find the y-intercept of this weird equation. Now the reason why it's weird is because of this minus sign sitting in front here, right? So it says find the y-intercept without converting it into standard form. Now in order to do that, you're just going to let x equal 0 and solve for and just simplify. So for the y-intercept, you're going to let x equal 0, right? So by letting x equal 0, you're going to get y is equal to negative bracket 0 plus 3 all squared plus 5. Now, here's what you have to do next. You have to simplify the bracket. What is 0 plus 3? It's just 3. So that means we have negative bracket 3 squared plus 5. So now, let's go again. Negative, and what is 3 squared? Isn't that just 9? Plus 5. But we still have our negative sitting in front, right? So, what is negative 9? Yes, it's just negative 9 plus 5. And now we just add, so now we end up with negative 4. So that tells us that the y-intercept is -4. And we are done. All right, your homework is online.